for different cases of end conditions of column to find the crippling load or buckling load. So it is nothing but the minimum load the column can take just buckling starts, till just buckling starts. Buckling means it is the failure of long columns. So crushing is failure of short columns. Buckling or crippling, it is the failure of long columns. I had explained all those things in the earlier classes. And we derived the Euler's formula to find the crippling load for long columns also, depending on different end conditions. So the end conditions we discussed were these four things. Both ends hinged. If both the ends of the column are hinged, PCR, buckling load or crippling load acting on the column, will be equal to pi square EI by L square, where this L is the actual length of the column. Then one end fixed and other end free, that is pi square EI by 4L square. Both ends fixed, 4 pi square EI by L square. One end fixed and other end hinged, 2 pi square EI by L square. So where L is the actual length of the column. So you can observe here in these all the four formulae. So this is important. Depending on the end conditions, you have to, in the problem, end conditions will be given. So once you know the end conditions of the column, so the suitable formula has to be used to find the crippling load. So in all the cases, you can see this pi square EI by L square is a common term. So in the first case, pi square EI by L square into 1. In the second case, pi square EI by L square into 1 by 4. Third case, pi square EI by L square into 4. Fourth case, pi square EI by L constant k, it will have a more column with both ends hinged, with both ends fixed, it is very high compared to the other conditions. So just by knowing the values of k, you can just substitute in this formula. So this L is nothing but the actual length. Now using this formula, you can define another thing called effective length. See here, effective length. So effective length is denoted by capital L. So you see the standard formula is normally taken for this both ends hinged. So both ends hinged is taken as the reference. By taking this as reference, because the value of k is 1 here, so you can always compute the value of capital L. So for the other cases, so what we do is, for both ends hinged case, we take capital L is equal to small l. That means effective length of the column is taken equal to actual length of the column. So capital L is equal to small l for the case of both ends hinged. That keeping that as reference, we can have the values of this capital L for other end conditions. See here, just I will tell you. See, in this formula, if you consider the second case, one end fixed and other end free, so keeping that pi square EI by L square same, so you can compare the denominators. So capital L square will be equal to 4L square here, 4 into small l square. See here, compare the two formulae. So if you compare that, capital L square is equal to 4 into small l square, means L will be equal to 2L. So square root you have to take both sides. So 2L. So you are going to get capital L is equal to 2L in the second case. Similarly, in the third case is, you can see here both ends fixed. In that case, pi square EI by L square into 4 is the formula. So you bring this 4 to the denominator. So it becomes 1 by 4. If you bring this 4 to the denominator, it becomes 1 by 4. So in that case, capital L square will be equal to L square divided by 4, or L is equal to small l by 2. So that is. Now lastly, you have one end fixed and other end hinged condition. Are going to get the capital L is equal to 2 into small l.
Sir.
Effective length is capital. Yes.
ಸರ್ ನಿಮ್ದು ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ಸರ್ ಅವಾಗ ಅವಾಗ.
ಒಂದು 5 minutes ಇರಿ, ನಾನು ಬೇರೆ ಕಡೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀನಿ. ವಾಯ್ಸ್ ಹೌದು, ಅದು ಏನು ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಇಲ್ಲ, ಆನ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಈಗ ಅಲ್ಲಿ ಕೇಬಲ್ ಇದೆಯಾ? ಈ ರೂಮ್ ಕೇಬಲ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಕೊಟ್ಬಿಡ್ತಾರೆ. ಸರಿ ಸರಿ. ಇಲ್ಲಿ ಒಂದಿದೆ, ಪಕ್ಕದಲ್ಲಿ ಒಂದಿದೆ. ಅದೇನೋ ಬ್ರೇಕ್ ಬ್ರೇಕ್ ಅಂತ. ಒಂದ್ಸಲ ಮ್ಯೂಟ್ ಮಾಡಿ ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಅದಕ್ಕೆ ಫ್ಯಾನ್ ಕೂಡ ಹಾಕಲಿಲ್ಲ ನಾನು. ಫ್ಯಾನ್ ಹಾಕಿದ್ರೆ ಶಬ್ದ ಬರುತ್ತೆ. ಕೇಬಲ್ ಇಲ್ಲ, ಅವತ್ತಿತ್ತು. ಇವರು 2 ಕೇಬಲ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಡಿಪಾರ್ಟ್ಮೆಂಟ್. ಕೊಟ್ಟಿರ್ತಾರೆ ಅನ್ಸುತ್ತೆ. ಹೌದು, ಇಲ್ಲಿ ಒಂದು ಇಲ್ಲೇ ಇರುತ್ತೆ ಪರ್ಮನೆಂಟ್, ಇನ್ನೊಂದು ಓಡಾಡ್ತಾ ಇರುತ್ತೆ. ಆಫ್ ಮಾಡಿ ಆನ್ ಮಾಡಿ ಅಂತಲ್ವಾ? ಅಲ್ಲ, ಮ್ಯೂಟ್ ಮಾಡ್ಬಿಟ್ಟು ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. Can you see the screen?
Yes, sir.
Okay. So here, is my voice clear?
Yes, sir.
To understand this Euler's formula, see here in the first case, both ends hinged condition. So it is taken as the reference. In that case, the formula for PCR is pi square EI by L square, where L is this capital L is the effective length of the column, small l is the actual length of the column. So it varies depending on the end conditions of the column. So both ends hinged condition is taken as the reference. Now, with respect to that, the other three conditions are compared. So, for example, one end fixed and other end free means the formula is pi square EI divided by 4L square. See here. Now the denominator here, it has got 4L square, but in the standard formula, it is pi square EI by capital L square. Okay. So that means if you compare those two, you will get capital L square is equal to 4 into small l square, or capital L is equal to 2 into small l, if you take the square root. So what I mean to say here is, in the case of one end fixed and other end free, your effective length of the column will be equal to 2 times the actual length of the column. So that we have to calculate and substitute in this formula only. So instead of substituting in this pi square by 4 into small l square, you can substitute in this pi square e into pi square divided by capital L square by taking capital L is equal to 2 into small l. Okay, that's all. So you should remember these three cases. So because in the problem, if they give actual, they will give actual length of the column. Small l value will be given. You calculate the capital L value, effective length of the column, depending on the end conditions. Then substitute that effective length capital L in the general formula. So general formula is pi square EI by capital L square. That is the general formula. The only thing is, if one end is fixed and other end is free, capital L is 2L. If both ends are fixed, capital L is L by 2. If one end is fixed and other end hinged, then capital L is small l by root 2. So these three conditions you should remember. Now if you observe here, in all the cases, your crippling load PCR is directly proportional to EI. That means EI is called as the flexural rigidity, okay, of the column, the product of Young's modulus and the moment of inertia. So here, Euler's crippling load is directly proportional to flexural rigidity, E into I, because it is there in the numerator. But it is inversely proportional to effective length, because it is L square is in the denominator. So what we can say here is PCR increases with increasing flexural rigidity, and it decreases with increasing length of the column, naturally. Okay. So as the length of the column increases, your strength of the column reduces. As the flexural rigidity increases, strength of the column also will increase. So these two things we now we can define this effective length of the column, capital L, like this. It is the length of the column for which the value of Euler's crippling load, PCR, will be equal to that for a column with both ends hinged. So this is the definition, because what we have done here is we have equated the standard case, that is both ends hinged case, to all the other cases. From that we have got the expression for the effective length. That is why this is the definition we are going to use. It is the length of the column for which the value of Euler's crippling load PCR will be equal to that for a column with both ends hinged. So whatever may be the end conditions of the column given, we are comparing that with the both ends hinged condition, and whatever length we are going to get for that case, so that will be your effective length. This is how it is defined. For example, see, I have given an example here. If both ends are fixed, let us say, if the actual length of the column is 3 meters, small l is 3 meters, then what will be the effective length? It is small l by 2. Capital L will be equal to small l by 2. Capital L is effective length, small l is actual length. So it becomes 1.5 meter. That is how we have to calculate. Suppose if it is a both ends hinged condition, same length if it is there, small l is 3 meters, then effective length is also equal to 3 meters because that is the standard case. Suppose if one end is fixed and the other end is free, then what happens? Capital L will be equal to what is the value? See here, 2L. So 2L means 2 times 3, 6 meters we have to take. So in the formula for finding the Euler's load, we have to take capital L as 6 meters. And in the last case, if one end is fixed and the other end is hinged, then we have seen that capital L is L by root 2. L by root 2, that means 3 divided by root 2. So if you calculate that value we have to take it as the effective length capital L, and we have to put that value in the Euler's formula to get the crippling load. Now let us see what are the limitations of this Euler's formula. So it has got some limitations also. So this is the formula. PCR is equal to pi square EI by capital L square. So this is the general formula where this L, capital L, depends on the end condition, as I already discussed. So this is the general formula. So depending on the end condition, this capital L value will differ. See here, normally this L is expressed in millimeters. K, let us take K as the radius of gyration, which I had explained on that day. It is the square root of I by A. Moment of inertia divided by cross-sectional area. It is the radius of gyration. So if you square both sides, you will get K square is equal to I by A, or I is equal to A into K square. Now you substitute this value of I in this formula 1. I is in the place of I, you put A K square. So substituting for I in 1, what you will get? PCR is equal to pi square E into I becomes A into K square divided by L square. Now divide both sides by A. So PCR divided by A is equal to pi square E into AK square divided by L square into A. So that A and A will get cancelled here. Now what has been done? This K square has been brought to the denominator. It becomes L by K whole square. So numerator will be now pi square E divided by L by K whole square. So this PCR by A. So PCR, as you know, it is the crippling load. Divided by A is the area of the column. Area of the column, depending on the cross section of the column, circular, rectangular, or square, we'll be knowing the area in millimeter square. So this is the crippling load divided by area. So load divided by area. So it is we can take it as stress. So FCR. So PCR divided by A is denoted by FCR. That is the crippling stress. So therefore, this PCR by A can be taken as FCR. FCR is equal to pi square E by L by K whole square, where L by K is known as the slenderness ratio. So this we have already defined there. Earlier also I had explained about the slenderness ratio when I classified the columns based on the slenderness ratio value as short column, medium column, or intermediate column, and long column. We used that word slenderness ratio. This L by K. So L is the effective length of the column. K is the radius of gyration of the column. This is known as slenderness ratio, this ratio. So you can see, if you call this as equation 2, from equation 2, as L by K decreases, FCR increases. L by K decreases. It is there in the denominator. So then FCR will increase. Okay. Because pi and E, they are constants for a given material of the column. As FCR depends on the type of material of the column, it should not exceed certain limiting value. So what happens? So this FCR value depends on the type of the material of the column. Just like for steel, for RCC column, the value is fixed. So it cannot exceed a certain limiting value. So therefore, what we can say, L by K cannot be less than a certain limiting value. So FCR will increase as L by K, the slenderness ratio value increases less than a particular value, because this FCR has got a limit depending on the type of the material of the column. Here, L by K cannot be less than a certain limiting value for a particular type of material of column naturally, because this L by K FCR is fixed. Since this FCR value depends on the type of material of the column, it has got some limiting value. Limiting means maximum value. Maybe, for example, for steel, 120 Newton per mm square. So it cannot be more than that. So when this is fixed, this also cannot be less than a particular value. Less than a particular. That is the restriction. So therefore, Euler's formula cannot be applied for short columns. So when this L by K will be less, so when L is less, effective length is less means for short columns. So Euler's formula cannot be used for short columns. So that is the limitation of Euler's formula that I had explained using that formula. So converting that I to AK square and substituting that in the once again in that formula, and from that you can see that FCR value for a particular material of the column, since it is restricted or has got a limiting value, so L by K value cannot be less than a particular value. That is the meaning. Now I will take an example for this mild steel column. If I take an example of mild steel column, for mild steel column, E value Young's modulus is 200 GPa or 2 into 10 power 5 Newton per mm square. That is the value. Because I am interchanging the denominator to numerator. So this value comes out 6579 L by K whole square, or L by K is square root of this, that is 81.11. What does it mean? So if you are using a mild steel column, then this Euler's formula is valid only if the value of L by K is less than 81. K value should, only if the value of L by K is greater than 81.8, 81.11. If it is less than 81.11, then this Euler's formula cannot be used. So that is the meaning. That means it should be a long column. So L should be more. So L by K should be greater than or equal to 81.11 in the case of mild steel column. So similarly for RCC column, you will be having some value of FCR, you will be having some value of E. So substitute that here. You will be getting a value for L by K for RCC also. So Euler's formula cannot be applied for an RCC column which has got a value of L by K less than that. So it is valid only if it is greater than or equal to this. So we have seen that in general what we can say, Euler's formula cannot be applied for short columns. It should be used only for limiting value. So L by K, that is tenderness ratio, cannot be less than a particular value. So on the value of L, effective length. If effective length is less, L by K is less. That is a restriction, and I had explained with respect to that mild steel column. Now, next formula is Rankine's formula. Are you hearing me?
Yes, sir.
Okay. So next we will see what is this Rankine's formula. So this the load carrying capacity of any type of column. See, so Euler's formula is used only for long columns. Please keep that in mind. But Rankine's formula, medium column as well as long column. Given it is given by, this is the formula. 1 by P is equal to 1 by PC. Load carrying capacity of the column. P means load carrying capacity of the column. PC is crushing strength of the column. So normally for short columns, we call this strength as crippling strength or buckling strength. So it is a combination. You can see here. So he has given Rankine has given a form it takes care of both PC and PCR. So this P is the actual load carrying capacity of the given column. Used for any type of column. Let us substitute. What is this PC? So PC is the crushing strength of column, which is given by crushing stress as crushing stress. You can make a note of that. Crushing stress is FC. So stress multiplied by the area of the column coming on the column. This is PC. And PCR, we know that it is Euler's formula. For finding PCR, we are using Euler's formula for long columns. So C into A, PCR is pi square EI by L square, where L is the effective length. P is equal to, if you substitute 1 by FCA, PC into PCR, the numerator becomes PC. And what the next step, what he has done, divide both numerator and denominator by PCR. You will be getting 1 by PC. Okay. So this is some simplifications you have to make. Reciprocal of this will be PC divided by 1 plus PC by PCR. Now you substitute for PCR. PC is FC into A. PCR is so 1 plus F. Now, as I already to A into K square. Moment of inertia is equal to area of the column multiplied by I is equal to AK square in this. FC into A divided by 1 plus FC into A divided by A square divided. See here. Plus whole square. So this is another part. Given material of the column. So please note that it is constant for a given material. Pi is another constant. So if you take the units, FC is expressed in Newton per mm square. E also is expressed in Newton per mm square. Pi no unit. So therefore it cancels. So no unit for. So this constant is called as Rankine's constant, that is denoted by alpha. It has no units. So please note that. So here, this FC by pi square E is called Rankine's constant for a given, and it is constant for a given material of the column. So you can make a note material of the column. For a particular material of the column, this constant is same. Now, if you put that in this place, if you put alpha, so it becomes P is equal to FCA divided by 1 plus alpha into N by K whole square. This is called as the Rankine's formula, which can be used for any Euler's formula. FC into A divided by 1 plus alpha into L by K whole square is Rankine's formula. So in a problem, they may ask you to find both Rankine's formula as well as Euler's formula for the same type of column. Okay. So now, what is the value of K here we have to take, because normally what happens, minimum K. On that day I told you minimum K minimum. If you want K minimum, it is given by root of I minimum divided by A. So in the case of rectangular column, so we have to be careful, because we have to take, there will be two values of moment of inertia in the case of rectangular column. One is BD cube by 12, another is DB cube by 12, because width and depth, they are different. One value of I. So Ix and Iy are equal. So you can take any one of them as a K minimum. But in the case of rectangular column, you have to take the minimum value of I, whether it is BD cube by 12 or D by 12, whichever is minimum, that value we have to take, and we have to substitute that in this formula. A is the area of the column to get the value of K in millimeters. See, so if you substitute that, you will get L is the effective on the end conditions, which I already told. So please make a note here. Both Fc and alpha are called as Rankine's constant. So okay, so both Fc and alpha depend on the material of the column. So in some books they say alpha is Rankine's constant. In some books they say constant. Don't worry. So anyway, they are constants only. So Fc has a unit of Newton per mm square. It is crushing strength of the material of the column. All. So these are the two formula you should remember. One is Euler's formula, another is Rankine's formula. Euler's formula is used only for long, and it is for its formula is PCR. We call it as PCR, crippling load, is equal to pi square EI by capital L square, where L is the effective length of the column. If you know the actual length of the column and the end conditions, then you can find out the effective length capital L and you can substitute in that. That is one thing. Second formula is Rankine's formula, which is given by P is equal to this Fc into A divided by 1 plus alpha into L by K whole square, where K is K minimum, which is root of I minimum by A, which can be used for any type of column, whether it is short column or long column or medium column. So these two are the important formulae you should know in the case of columns. One, a 2 meter long column has a square cross section of 40 mm by 40 mm. So it's a square column. Length of the column is actual length. Whatever length is given, you have to take it as actual length, small L. It is not capital L. So here 40 mm by 40 is the size of the column. So area becomes 40 into 40, 1600 millimeter square, capital A. Taking factor of safety is equal to 4, determine the safe loads. Safe load. Safe load is given by maximum load divided by factor of safety. Maximum load is your PCR, maximum load. So PCR divided by factor of safety gives the value of safe load. So two conditions he has given. One is if the ends of the column are thing is depending on the end condition, you have to get the value of that cap. So MPA. So 2 into 10 power 3 Newton per mm square or MPa. So you have to convert to Newton per mm square. Be careful. Right? So what may be the unit they give in the exam, convert that into Newton, substituting the problem answer so in the formula. So L also it is in meters, convert that into millimeter. So your Newton and millimeters. Factor of safety is 4. So safe load is PCR divided by factor of safety. Now in the case of both ends, by L square, calculate the value of I first here. Column. So I is BD cube by 12. So here B is equal to D. So B is also 40, D is also 40. So 40 into 40 cube by 12. Or you can write it as into 10 power 3. So K means into 10 power 3. You can write into 10 power 3 millimeter power 4. Area of the column is 40 into 40, 1600. So K value is here root of I by A. Please note that K value is root of I by A. So if you substitute that, and of course here K value is not required. K value is required only in the case of Rankine's formula. Okay. So here pi square into E is 2.1 into 10 power 5 into I is this value divided by L square. So in the case of things hinged case, capital L is equal to small L. So you have to put the capital L as 2000. So if you simplify this, you will get in newtons. Please note that you newtons, then convert it into kilonewton. Okay. So you please check it whether the answer is correct. Pi square into 2.1 into 10 power 5 into 213.33 into 10 power 3, 2000 square. It will be in newtons. Check that. Tell me the answer. Whether you get the same value. Then whatever you are going to get in Newton by 1000, you will get in kilonewtons. Pi square into 2.1 into 10 power 5 into 213.33 into 10 cube divided by 2000 square. Check it.
Sir, 11042.57.
28. Sure. 110.2 na.
11042.
ತೊಂದ್ರೆ ಇಲ್ಲ ಇಂಟು 10 ಪವರ್ ಡಿವೈಡ್ ಬೈ 1000 ಮಾಡಿ, ಅದು ನ್ಯೂಟನ್ ಅಲ್ಲಿ ಇರ್ತದೆ. ಡಿವೈಡೆಡ್ ಬೈ 1000 ಇಷ್ಟು ಬರುತ್ತಾ?
11.042.
ಬರುತ್ತಾ? ಇಲ್ಲ 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 ಇಲ್ಲ, ಏನೋ ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ. 11 ಬರಲ್ಲ. ಇಲ್ಲಿ ನೋಡಿ, ಪೈ ಸ್ಕ್ವೇರ್ ಇಂಟು 2.1 ಇಂಟು 10 ಪವರ್, ಅದು ಈ ವ್ಯಾಲ್ಯೂ. ಈಗ ಈ ವ್ಯಾಲ್ಯೂ 213.33 ಇಂಟು 10 ಪವರ್ ಎಲ್ ಅಂದ್ರೆ 2000 ಸ್ಕ್ವೇರ್.
Yes, sir. ನಾನು 10 to the power of 2 ಅಂತ ತಗೊಂಡಿದ್ದೆ ಸರ್. 10 to the power of 3 ತಗೋಬೇಕು. ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಬರುತ್ತೆ ಸರ್.
10 ಪವರ್ 3 ತಗೋಬೇಕು. ಅದು ಆನ್ಸರ್ ಇದೆ ಆಯ್ತಾ. ಡೈರೆಕ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಇದು, ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್. ಸೇಫ್ ಲೋಡ್ ಅಂದ್ರೆ PCR ಡಿವೈಡ್ ಬೈ ಫ್ಯಾಕ್ಟರ್ ಆಫ್ ಸೇಫ್ಟಿ. ಸೊ ಫ್ಯಾಕ್ಟರ್ ಆಫ್ ಸೇಫ್ಟಿ 4 ಅಂತ ಕೊಟ್ಟಿದಾರಲ್ಲ ಇಲ್ಲಿ. ಸೊ ಅದನ್ನ ಹಾಕಿ. ಸೇಫ್ ಲೋಡ್ ಕೇಳಿದ್ರೆ ಫ್ಯಾಕ್ಟರ್ ಆಫ್ ಸೇಫ್ಟಿ ಕೊಡ್ಬೇಕು ಅವರು. Factor of safety, then you cannot find out safe load. You can just leave PCR ಅಷ್ಟೇ. So our 27.63 is the kilonewton is the safe load. This is for both ends hinged. Now you take both. Effective length L/2 ಆಗುತ್ತೆ. ಇದನ್ನ ಜ್ಞಾಪಕಬೇಕು. That's what I told. 4 cases. So L/2 ಬರುತ್ತೆ. So small L ಇಲ್ಲಿ 2 meters ಅಂತ 2 meters ಕೊಟ್ಟಿದ್ದಾರೆ. So capital L will be ಎಷ್ಟು ಬರ್ತಾಗ 2 divided by 2 1000 mm. So in the place of 2000 you have to take 1000 ಅಷ್ಟೇ, ಬೇರೆ ಏನು ಡಿಫರೆನ್ಸ್ ಇಲ್ಲ. ಪೈ ಸ್ಕ್ವೇರ್ EI ಸೇಮ್ ಇರುತ್ತೆ, L will be 1000. ಅವಾಗ ನಿಮ್ಗೆ ಆನ್ಸರ್ ಇದ್ರ 4 ಅಷ್ಟು ಬರುತ್ತೆ, ಇಂಟು 4 ಟೈಮ್ಸ್ ಬರುತ್ತೆ ಅಷ್ಟೇ. ದಟ್ ಈಸ್ ದಿ ಆನ್ಸರ್. ಡಿವೈಡ್ ಬೈ 4 ಮಾಡಿದ್ರೆ ಅಷ್ಟು ಬರುತ್ತೆ ಅಷ್ಟೇ. ಅದು 1000 ಹಾಕೊಳ್ಬೇಕು ನೀವು. ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ 1000 ಇನ್ ದಿ ಪ್ಲೇಸ್ ಆಫ್ 2000. ನ್ಯಾಚುರಲಿ ವಿಲ್ ಗೆಟ್ 4 ಟೈಮ್ಸ್ ಮೋರ್. ಅದು ಅವತ್ತೇ ಹೇಳಿದ್ದೀನಿ, 4 ಫಿಕ್ಸ್ಡ್ ಕಂಡೀಷನ್ ಇದ್ರೆ ಕಾಲಮ್ ಸ್ಟ್ರಾಂಗ್ ಇರುತ್ತೆ. ಬರುತ್ತಲ್ವಾ?
Yes, sir.
ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಅದು. Based on the end condition of the column, whether it is hinged or fixed or both ends hinged or both ends fixed, 4 ಕಂಡೀಷನ್ ಯಾವ್ದು ಬರುತ್ತೆ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ we have to decide the value of L ಅಷ್ಟೇ. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ನಾನು ಬ್ರೇಕ್ ಕೊಡ್ತೇನೆ, HOD ಕ್ಲಾಸ್ ನಾನೇ ತಗೊಳ್ತೇನೆ. 10:45 ಜಾಯಿನ್ ಆಗಿ, ಆಯ್ತಾ? ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ ನಾನು. ಮಧ್ಯಾಹ್ನ ತಗೊಳ್ಳಲ್ಲ ನಾನು, ಮಧ್ಯಾಹ್ನ 3:15 ಕ್ಲಾಸ್ ಇರೋದಿಲ್ಲ. ಈಗ 10:45ಗೆ ಕನೆಕ್ಟ್ ಆಗಿ ಮತ್ತೆ ಸ್ವಲ್ಪ. ಈ ಕ್ಲಿಯರ್ ಕೇಳ್ತಾ ಇದೆಯಾ?
Yes, sir.
ಅದೇ ಹೇಳಿ ಸ್ವಲ್ಪ. ಏನ್ ಮಾಡೋದು, ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಒಂದೊಂದ್ಸಲ ಕ್ಲಿಯರ್ ಇರುತ್ತೆ, ಒಂದ್ಸಲ ಇಲ್ಲ. ಸೊ ಐ ವಿಲ್ ಕಂಟಿನ್ಯೂ at 10:45.